This steel monster became a symbol of the golden age of aviation, frightening and inspiring just by its appearance, with solutions that turned the industry upside down, a height that left all records behind, and speed, speed, speed. Ironically, the aircraft that became the personification of high-speed aerial warfare was destined to put an end to it. Hello aviators, Sky here, and today we will meet the champion of the Interceptor League. I present to you the MiG-25. The second half of the 20th century became the apogee of the aviation race, the intersection of insane technological development and no less insane ambitions. Flight speeds and altitudes that seemed incredible just yesterday were no longer impressive today. Airplanes that left behind the records of their piston predecessors soon left behind the sound barrier. The coveted Mach numbers became just a bar to overcome for increasingly advanced combat vehicles, fighters and bombers. And by the end of the 1950s, parity had formed between the leaders of the Cold War. Whatever you can do to the enemy, he can do to you. Which means that having seen bombers in the sky flying towards the enemy, it was necessary to meet the already arriving bombers of this very enemy. Having created offensive weapons, the parties immediately set about creating protection against them. Moreover, for the USSR, this problem was critical. The United States had a gigantic fleet of strategic bombers, and it was necessary to defend a no less gigantic territory. There were two solutions to this problem. First, surface-to-air missiles that could attack targets at different speeds and altitudes. But the missile umbrella was small, optimal for a base or city, but it was simply impossible to cover an object the size of the USSR with it. The second solution, the best means of fighting an aircraft is another aircraft, and the basis of the air defense forces were interceptors. But they also had drawbacks, first of all limited speeds and altitudes, which made it difficult to fight, for example, the high-altitude U-2 reconnaissance aircraft, which did not hesitate to fly directly over the country's territory. And these were simple and slow vehicles, which could soon give way to formidable, high-speed machines, and not only scouts like the Archangels, but also bombers like the Valkyries. At the same time, such machines as the Su-15 and Tu-128 were already being created, but having decent performance for their time, they would not be able to meet the challenges of the near future. Everyone was waiting for a full-fledged solution, which was supposed to become the brainchild of the design bureau of Mikoyan and Gurevich, the famous MiG. What was required of them? The design bureau received the first resolutions on the creation of a fighter-interceptor back in 1956, and they contained the following figures: altitude 20 to 25 kilometers, flight speed Mach 2.5 to 3, about 3,000 kilometers per hour. The aircraft had to be supplied with all the necessary equipment, a powerful radar and advanced air-to-air missiles. Besides, since they were talking about the main interceptor of air defense forces, it had to be mass-produced, which means it should be quite cheap to manufacture and maintain, not too demanding on infrastructure, and accessible to a large number of pilots. And don't underestimate these limitations. You can make the coolest fighter in the world, but with limited deliveries and the impossibility of providing constant service, it will be useless. I note that the Avro, North American and Lockheed projects were not implemented not because they were bad, but because they went beyond this scope. Engineers had to somehow balance between requirements and constraints. For a long time, such an aircraft seemed more like a thought experiment, and the main obstacle to its implementation was the lack of an engine capable of operating efficiently at speeds of Mach 3. But an option was found.
6, 5, 4, 3, 2, 1, 0.
In the 1950s, cruise missiles experienced their rise, and in the USSR, the Tu-121 project was developed, a cruise missile that was supposed to fly at altitudes of more than 20 kilometers, at speeds of about 2,700 kilometers per hour, very close to what the MiG needed. The Tu-121 did not go into production. Ballistic missiles won back then, but the legacy remained. The KR-15 is a huge turbojet engine, very powerful and adapted for high-speed flights. Its outstanding capabilities had a price. The engine had to operate at supersonic speeds, and at low speeds its behavior was mediocre. In addition, the flight resource was only 15 hours. For a cruise missile launching on solid fuel boosters and flying one way, this was normal, but not for an airplane. A lot of work was done on the engine. They modified it, expanded the range of operating speeds, and increased the resource, first to 50 hours and later with the development of the program to 300 hours. The figure is still not impressive, but it's something. The thrust had to be reduced, but remaining within the range of 7.5 tons force without afterburner and up to 11.2 tons force with afterburner, they were quite suitable. So the MiG received its engine, the R-15B-300, and it was now possible to take on the plane. Several prototype versions of the YE-150 and YE-152 were created. In terms of the general layout, the aircraft remained classic, reminiscent of the large MiG-21. But the more actively the aviators drove the prototypes, the more clearly they realized that they would not achieve the required performance. There was no room in the nose cone for a large radar. There was not enough space in the fuselage for equipment and fuel, and at speeds above Mach 2, control problems began. And the point was in the layout itself, which hit the ceiling. There was simply nowhere to improve it. Something completely different was needed. A big push for the actual restart of the project was the incident with the Lockheed U-2 reconnaissance aircraft, shot down in May of 1960. This was a success for the USSR air defense, but the devil, as always, is in the details. The winged paparazzi was shot down over Sverdlovsk, having previously flown half the country. Interceptors chased it for several hours, but without doing anything to it, they gave the trophy to the S-75 surface-to-air missiles. In the debate about which is better, a missile or an airplane, a weighty argument emerged, because the missiles did the job, and the airplanes did not. The aviators were under serious pressure. The updated project received the index YE-155, and while on the YE-152 the designers behaved conservatively, now it seemed they had released all the brakes. The old layouts were discarded, and the aircraft was drawn from scratch, collecting all the possible achievements of aviation from all over the world. I think it's time to get to know what they have done live. We are in the Patriot Park, not far from Moscow, and in front of us is a MiG-25. The MiG-25 PU. I'll tell you why it is so strange and has two cockpits a little later. The new aircraft received a free large nose, air intakes on the sides, a trapezoidal wing, and a two-fin tail. It was a huge leap. It seemed that yesterday's YE-152 is closer to the old MiG-21 than to the YE-155. By the way, it did not become like this right away. At first, they wanted to leave the wing more familiar, like on the old prototypes, but research forced them to abandon the classics in favor of a large, thin trapezoid with a slight sweep. This arrangement was a compromise. It slightly increased drag, but together with the upper fuselage, it provided decent lift, improving the aircraft's behavior at low speeds. High-lift devices are simple: ailerons and flaps, no slats. The tail unit was also initially planned to be single-finned, with a pair of all-moving horizontal stabilizers on the sides of the engines. However, after a series of tests, it was decided to abandon the single fin. At Mach 3 it either stopped working, or it would have to be made huge. Thus, the tail received two fins, plus a pair of vertical fins at the bottom. An avant-garde solution for that time, but as practice shows, very successful. Of the remaining elements, two brake flaps were placed on the tail above and below the nozzles, plus a brake parachute was placed on the top of the fairing. The landing gear is tricycle. The front leg is two-wheeled, the main gears received one hefty wheel each. The loads on the landing gear and on the ground are large, however it is possible to save the scarce volume inside the aircraft. Meanwhile, the seemingly simple layout has many nuances. The nose is slightly lowered, the wing consoles are located at an angle from the horizontal, the tail fins are slightly spread out to the sides, and the engine thrust vector is tilted slightly upward. Little things in the struggle for aerodynamics in conditions of limited thrust and the enormous required speeds. Another point in this struggle is to make the plane as compressed as possible. I hear a comment: compressed? Have you seen this elephant? With a length of 21 to 22.3 meters depending on the version, a wingspan of 14 meters and a height of 6.5 meters, it is not so much thin as a hungry student, but rather dry like a bodybuilder before a competition. Healthy, but not an ounce too much. Its layout is as dense as possible, and the main reason for its epic dimensions is the power plant. The R-15B-300 engine is one of the few parts that was directly transferred from the old prototypes to the YE-155. But we are talking specifically about the motor. Everything that surrounds it is made from scratch. The plane received two huge engines, so in order to maintain at least some adequate compactness, they had to be pressed together. The result can be seen in the tail. The large adjustable nozzles are intersecting. No less important elements were the air intakes, which played a huge role in the performance of the power plant and therefore the entire aircraft. At the entrance there are two huge wedges with adjustable lower doors. The inlet has several intake ramps, slots for removing the boundary layers, as well as a turbulator right in the middle. They all work in such a way that as air passes through, it is slowed down and compressed. The logic here is simple. If wind flies into the blades at a speed of 3,000 km per hour, the blades will fly away with it. But the inlet protects them and, at the same time, acts as a kind of additional compressor. Besides, the dynamic mechanism allows the flow to be adapted at different speeds and altitudes, which is important for ensuring good performance in different flight modes. Without such support, a specialized high-speed engine would struggle. One of the main problems of flying at Mach 3 is the temperature. At this speed, the plane heats up to 250–300 degrees Celsius. Aluminum alloys, which are often used in aviation, are simply not able to withstand this. An obvious solution at first glance was to use titanium, which would cope with this quite well. But titanium is very expensive and difficult to process and repair. If we are talking about some unique plane, fine. But a mass-produced aircraft cannot be made this way. The alternative is steel. Heat-resistant, durable, and non-thermal conductive, moreover much more affordable, which was the reason for choosing it as the basis. 80% of the aircraft structure is made of steel. The side effect is that steel is heavy. The dry weight of the aircraft reached 20 tons, which means that without weapons and fuel, it weighed more than a fully equipped Su-15. The Interceptor's maximum takeoff weight reached 36.7 tons. Other versions easily exceeded 40 tons. For comparison, this is the mass of the Embraer E-170-175 regional airliners, and at the level of the huge Tu-128. The next challenge for engineers was the fight against the chronic disease of high-speed interceptors. Good aerodynamics required the airframe to be compressed, reducing the space for fuel reserves, the result of which often was a very modest range. Almost the entire available internal volume of the MiG was occupied by fuel tanks, 6 in the fuselage and 4 in the wing. In some versions there were even tanks in the fins. Meanwhile, there are no tanks themselves. Their role is played by adopted free volumes. This increased the fuel volume but had a side effect. The huge range of operating temperatures in flight causes noticeable compression and expansion of the hull materials, and such tanks leak. This happened on some high-speed aircraft, but in the case of the MiG, in which the tanks were in the same volume as the engines, fire was guaranteed. The problem was solved radically. The classic aviation method of riveting was discarded and was replaced by welding, which turned entire sections of the aircraft into rigid, monolithic parts. Fuel, the special T6 kerosene with a high ignition temperature. Plus, as it is used up, the tanks are filled with nitrogen, an inert gas that prevents anything in sight from burning. useful solutions for storing fuel at supersonic speeds inside an actual furnace at a temperature of 150–180 degrees. The total mass of fuel in the MiG could reach 14.5 to 15 tons. It was also possible to attach an additional tank, although apparently this was not practiced very often. The cockpit was also a major challenge for engineers. They needed to combine the resistance of the glazing to high loads and temperatures and the requirements for good visibility of a combat aircraft. A metal cap with windows cannot be installed here. Especially for the MiG, a new heat-resistant plexiglass was created, which with a thickness of 2 cm in the frontal part and integrated cooling, could withstand heating up to 230 degrees. Similar glasses were later used on other high-speed aircraft. They can be easily recognized. During long-term storage, especially under the sun, they become cloudy. The lack of internal space did not allow the aircraft to accommodate a second crew member, making the MiG-25 the heaviest single-seat combat aircraft. In order not to place excessive work on one person, the aircraft was very seriously automated. Control of the power plant, control of most systems, and even an autopilot. The communication system between aircraft and with the ground was also developed. The aircraft was created not as an autonomous interceptor, but as an air component of a large air defense complex, including serious ground infrastructure. The RP-25 Smerch-A airborne radar system was one of the reasons for changing the nose of the aircraft even at the stage of design development. Originally created for the Tu-128, it was quite powerful, detecting targets at a distance of about 100 kilometers and could track them at a distance of 50 kilometers. Later the planes were modernized, which I will talk about later. As a bonus, I can't help but mention a little twist that made everyone love the MiG-25 even more. The onboard equipment received a complex cooling system, including various liquids. One of them was a mixture of alcohol and water, which if you were in good health you could drink. The famous Masandra, whose name was a reference to a popular alcoholic drink, as well as a comic abbreviation that was deciphered as Mikoyan Artyom, glorious son of the Armenian people, giving joy to aviators. On average, about 180 liters of joy to aviators on board. Masandra itself was not something unique specifically for the MiG and was used on other aircraft, but the 25th became its most famous carrier. Mikoyan's design team began to work closely on creating the aircraft in 1961. From the very beginning, it was decided to make 2 versions at once, the basic Ye-155P, перехватчик or interceptor, and the Ye-155R, разведчик, reconnaissance aircraft, because with such performance, why not? In 1964, both machines had already entered the prototype assembly stage. In March 1964, the reconnaissance aircraft made its maiden flight, and in September of the same year, the interceptor took off. During the testing process, the aircraft were changed and modified, so one should not be surprised at various exotic solutions on early aircraft, some of which were adopted and some over time discarded, resulting in the aircraft that we know now. Over the next few years, the aircraft were actively tested, but all work was strictly classified. The curtain opened in 1967, when 4 aircraft took part in the air parade in Domodedovo, near Moscow. This was the first public demonstration, which caused a lot of emotions among spectators, especially among unusual spectators, who eventually gave the aircraft the NATO index FoxBat. An aircraft flying at speeds of about Mach 3 was considered the limit of capabilities, which only the A-12 and XB-70 could reach. But it turned out that the communists already have it. In addition, foreign intelligence services came to the conclusion that they are full-fledged multi-role Mach 3 fighters. The reaction was stormy. One can of course say that the Americans went too far with drama in their assessments. There was no serial production in 1967, and the vehicles being created were not multi-role fighters at all. But as they say, nothing speeds up progress more than frightened officials untying the hands of their engineers. Eventually, the result of emotions of that time was the F-15 Eagle, which in fact was more inspired by the fantasies about the Soviet multi-role fighter than by the real MiG itself. But the real MiG was not simple at all. The revolutionary aircraft had many features, some of which turned out to be surprises for the testers, sometimes pleasant, sometimes problematic, sometimes leading to disasters. Nevertheless, they managed to tame the mighty Stallion. The planes rushed to break records. At first, it was a flight of a 1,000-kilometer segment at a speed of 2,319 kilometers per hour, already more than Mach 2. And by 1967, the speed reached 2,921 kilometers per hour. In October of 1969, the reconnaissance aircraft was put into service, receiving the official designation MiG-25R. The tests of the interceptor were more complex, so it reached service acceptance in 1972, and thus the MiG-25P was born. The production of the aircraft was established at the facilities of the Gorky Aviation Plant, the current Sokol, and for the plant, this task was no less difficult than for the creators of the aircraft. They had to switch to the MiG-25 from the MiG-21, which next to this monster seemed like a sparrow. The most difficult task was mastering the production of steel components and their welding. As part of this work, a huge number of new technologies, methods, and equipment were created, including entire complexes of automated welding of sections. The MiG in some places looked more like a tank than an airplane. But despite the extremes, everything worked out. And the balance between price and efficiency was maintained. The MiG-25 was of course more expensive and more complex than its combat brothers, but remained within the framework that allowed it to be mass-produced. The numbers speak for themselves. Between 1969 and 1985, about 1,190 aircraft were produced, and at the peak of the series in the second half of the 1970s, almost 90 of them were made per year. Mastering the aircraft also turned out to be not too difficult, and the training versions were especially helpful in this matter. When they were created, it was decided to redo the nose, remove the radar, and put a second cockpit there. It looks strange but familiar. The training A-12 Titanium Goose or the training Tu-128 were no less strange. Actually, this is exactly the aircraft that stands in front of us, the MiG-25PU. They did the same with the reconnaissance aircraft, creating the MiG-25RU. Working in the cockpit was quite comfortable, as long as you keep an eye on the modes, don't exceed the speed limit, and do not touch the windows. They turned into a grill oven at Supersonic. Sometimes the disadvantages of working alone became apparent. Even with automation, in combat conditions it was difficult to keep track of everything. The equipment was more reminiscent of spacesuits and was very helpful in normal and extreme conditions. There have been cases of ejection on the MiG-25 even at Mach 2, and this is something you definitely wouldn't want to do. Extreme, traumatic and painful, but not fatal. And how did all this fly? The takeoff looked incredibly impressive. The afterburner would not let me lie. However, this was not like shooting a slingshot. The heavy plane accelerated and took off from the runway quite calmly. But then it got faster. From the moment of takeoff to the moment of reaching a height of 20 kilometers at supersonic speed, 5 minutes passed at most. And this is an ordinary flight. The planes that set records did it even faster. And up there, the MiG felt at home. The engines were most efficient in supersonic flight and kept the cruising speed of about Mach 2.35, approximately 2,500 kilometers per hour. What for others was a maximum, here was just a normal mode. But they still wanted it faster. The maximum cruising speed that could be maintained for a long time was Mach 2.65, about 2,800 kilometers per hour. The maximum permissible speed was Mach 2.83, 3,000 kilometers per hour. But it was impossible to maintain this speed for long. The heating became so severe that began to melt the canopy, so it could withstand no more than 5 minutes. The engines could hold the limit for about 15 minutes, but they paid for it in resource. It was necessary to slow down and cool down, and then pick it up again, so the MiG did not fly at 3,000 km per hour, but rather jumped. I would like to emphasize that this limitation was purely based on maximum structural loads. The plane itself had such a crazy thrust that it could have accelerated beyond Mach 3. This happened from time to time, but it was strongly not recommended to do this. Flight altitudes are in accord. Service ceiling with missile suspension is 22 kilometers, without 25 kilometers. At such altitudes, the sky already becomes dark, and the horizon of the Earth becomes rounded. And this is not the limit. In 1977, the plane jumped to a height of 37,650 meters. 37 kilometers is the width of the English Channel, only vertically. Flight ranges depended on many factors, both on the load and on the scale of use of the fuel tank's best friend, afterburner, without which supersonic speed was inaccessible. At subsonic, the plane flew about 1,700 kilometers, at supersonic about 1,200 kilometers. In combat mode, the interception line, that is, the distance from the airfield to the limit and back, was around 600 kilometers. If it was necessary to catch a fast and high-altitude target, 450. There were also extreme scenarios when the plane intercepted the enemy at any cost, at maximum range without returning. On the one hand, this is a one-way ticket. You eject somewhere over the Arctic Ocean and wait for rescue. On the other hand, in the conditions of a nuclear war, this does not seem like much of a drama. Next, we should talk about weapons. In conditions of high-speed interception, a gun was useless and was not installed, giving all the work to missiles. The main caliber of the MiG-25 was the R-40 air-to-air missile, NATO designation AA-6 Accurate, created specifically for the interceptor. Its feature was also resistance to high-speed conditions, titanium hull, heat-resistant fairing, cooling of internal components. Two versions were created, the R-40T with a thermal homing head and R-40R with a semi-active seeker. The oncoming firing range is 36 kilometers. By modern standards, not an impressive figure, but then it was very decent. Under the wing of the MiG, 4 missiles were suspended on pylons. With lengths of 6.5 meters and weight of 450 kilograms, they looked impressive. As I already noted, the MiG-25P was part of a large air defense infrastructure, with radars, command posts, and other aircraft. Its autonomy was rather conditional. Just flying and looking for a target is inefficient, especially when the target is a metal arrow with an atomic bomb, rushing at a speed of Mach 3. In such conditions, the only way is to detect the target from the ground and shoot it down with the interceptor. In fact, the only way to intercept was to fly on a collision course and shoot it in the face. I must emphasize that the missile range of 36 kilometers is precisely on a collision course. Maneuvering or catching up was out of the question. With acceptable overloads of about 4.5 G at Mach 3, the MiG maneuvered slightly better than a ballistic missile. This applied to all racers. For example, the SR-71 turning around could paint a circle with the diameter of a small country. It was possible to maneuver at low speeds if the target was, for example, a B-52, but simpler aircraft could handle that. The MiG-25 was good precisely at high-speed interception. It did not pretend to be a multi-role fighter. At low speeds, the MiG-25 flew decently, but without miracles. The engines designed for supersonic performance had its effect. Fuel efficiency was mediocre, and throttle response was not encouraging. This, in principle, is typical for all jet engines, but here there was a lag of 10 to 15 seconds. Unpleasant. However, the airframe that generates decent lift has made it possible to alleviate one of the problems of high-speed aircraft, the terrible performance at minimal speeds. The landing speeds of many machines of that time were around 320 to 350 km per hour. This is a lot. For the MiG-25, it was around 290 to 310 km per hour. Compared to conventional aircraft, it was still not great, but in its league, it was considered more or less comfortable. The takeoff run was 1200 meters, and landing with a braking parachute was 800 to 900 meters. Not much, which greatly simplified operation and did not require expensive modernization of airfields. The airplane's impact on the big picture was radical. The 1950s and 60s were an era of cat-and-mouse games between spy planes and air defense systems. The U-2 initially showed poor interceptor performance, but was vulnerable to surface-to-air missiles. The A-12 and SR-71 at speeds of Mach 3 overcame the missile problem. The S-75, which easily shot down the Dragon Lady, turned out to be practically useless against them. And the Archangels were met by the MiG-25. I'll say right away that comparing the MiG-25 and SR-71 is completely pointless, a couple of common features in a sea of radical differences. But I'll tell you about their relationship. Often, everything happened according to the usual scenario. Blackbird flew up to Soviet airspace, there it was met by MiGs, and they flew along the border in a friendly flock. The SR conducted electronic reconnaissance, and the MiGs made sure it did not go where it shouldn't. The MiG was inferior in range and maximum speed. Blackbird would have been difficult to shoot down, but getting cocky was still dangerous. One time, the Scout almost got caught. In 1987, the SR-71 had an engine failure while on a reconnaissance flight over the Baltic Sea. Naturally, having lost speed and altitude, the plane practically handed itself over on a silver platter, and the MiGs flew to intercept it. They really wanted to get the machine and see how all this beauty works. But there was no time. The Swedish Saab 37s quickly arrived at the damaged plane. They did not shoot at the escort, and the wounded bird left for Denmark. By and large, with the advent of the MiG-25, the attempts by the American aerial reconnaissance aircraft to cross the border ended, just as the concept of high-speed, high-altitude penetration as a whole ended. Machines such as the SR-71 continued to serve, but did not enter Soviet airspace, and the XB-70 bomber project was closed. Trying to break through swarms of MiGs would have been suicide for them. But while the work on Scouts could have been transferred to satellites, no one was going to retire bombers. Thus, a new concept emerged: low-level penetration, when bombers hugging the ground fly so low that radars cannot detect them, and interceptors cannot see them well against the background of the Earth. This task was implemented in projects such as the F-111. This concept was a serious challenge and required that Soviet interceptors learn how to deal with low-level targets, aircraft and cruise missiles. The work was carried out within the framework of several projects involving both local modernization and radical changes. At the beginning, the work was carried out calmly, but it had to be accelerated. On September 6, 1976, radar stations of the Japan Air Self-Defense Force detected an unidentified aircraft flying towards the island of Hokkaido. Sometime later, the plane landed at Hakodate Airport, the MiG-25P, piloted by Viktor Bilenka. It was an epic international scandal, first between the USSR and Japan, then also with the USA, which immediately gave the pilot political asylum. American intelligence could only dream of such a trophy. A detailed study of the aircraft greatly changed the Americans' opinion about it, and with some disappointment, because many of their assumptions about maneuverability, multi-purpose and fighter capabilities turned out to be exaggerated. In front of them was a purebred interceptor. Here, I simply have to address the theory that Bilenka stole the MiG-25, the Americans studied it, and created the F-15 on its basis. First, the MiG arrived in Japan in September 1976. At that time, the F-15 had already been put into service. It was a bit too late to copy technology. Second, external similarity. Yes, the MiG and its layout inspired the creation of the Eagle, just as quite likely, the Vigilante layout at one time inspired the creation of the MiG. the circle of inspiration, even if you look very superficially and do not notice the huge differences between a carrier-based bomber, a high-speed interceptor, and a multi-role fighter. Let's get back to history. For the USSR, this hijacking was a serious blow, and it was not so much about revealing the aircraft's capabilities as revealing the performance of equipment, communication systems, and air defense infrastructure. The solution to this problem was to make large-scale changes to the equipment. As part of this work, the problem of protection against low-level penetration and general improvement of performance was also solved. Since we are redoing it, why not do it all? This is how the MiG-25 PD appeared. The aircraft received practically a new set of onboard systems and a new Sapphire 25 radar, which saw at a distance of 120 kilometers and could track several targets at once at a distance of 75 kilometers. The MiG learned to effectively combat low-level flying targets and received the new R-60 missiles, NATO designation AA-8 AFID. Their firing range was small, 7 to 10 kilometers, but on the other hand, 2 of them could be hung on each pylon at once. The R-40TD and RD missiles were also improved, receiving more effective guidance systems. The MiG-25 PD was a compromise modification. It began to be mass-produced, and the already produced P-version aircraft were updated to this version, but it could not meet the new challenges completely. This was to be done by another, more radical project, a new interceptor capable of engaging targets at a wide range of altitudes and speeds. And it came true. We know it under the index MiG-31. Naturally, the aircraft had many other modifications, and looking at such variety, engineers proposed more and more exotic solutions, from new versions of interceptors, fighters and bombers, to machines with variable sweep wings, and of course, as we love, an administrative passenger supersonic aircraft. But these roles were occupied by other, more adapted machines, and the business jet in general has not moved anywhere since then. While on the territory of the USSR, the main roles were played by the interceptors, outside the country at first, reconnaissance planes were used. In the 1970s, the Soviet MiG-25R periodically flew over Iranian territory. It was a response to the Dark Gene and IBEX projects, intelligence operations carried out jointly by the CIA and Iranian Air Force. Yeah, that actually happened. Eventually, after the Islamic Revolution of 1979, this game was over. For the first time, the MiGs found themselves in real combat conditions in the early 1970s, when Soviet reconnaissance planes were transferred to Egypt and flew over Israel. The Israeli Air Force tried to intercept them, but neither air defense missiles nor the F-4 and Mirage 3 fighters could do anything to it. Although once running from them, the MiG-25 accelerated to a speed of Mach 3.2, almost 3,400 km per hour. These flights helped formulate a fairly detailed defense plan for the region, which was one of the factors in the success of the Egyptian army at the beginning of the Yom Kippur War in 1973. At the same time, not only the reconnaissance capabilities of the MiGs were a cause for worry, but also the bomber capabilities. Back in the late 1960s, the military began to think about the prospects of creating a high-altitude, high-speed bomber. Thus, the MiG-25RB was created on the basis of the reconnaissance aircraft. The aircraft retained reconnaissance functionality, but received additional equipment that allowed it to bomb targets from an altitude of more than 20 kilometers, at a speed of Mach 2.5. The accuracy, however, was in question, but in extreme cases, a miss could be compensated by expanding the affected area of a nuclear bomb. Later, other versions were created, the final of which was the MiG-25BM, which received the Ha-58 missiles designed to destroy radar stations, a counterpart of the AGM-88 HARM missile. Both appeared at the turn of the 1980s, and both are still in use. Naturally, demonstrating such capabilities, the MiG-25 became a desirable weapon. The Soviet Union supplied these aircraft quite willingly, although I must add, supplied only them, without deploying a complex air defense system as they did at home. From this we can conclude that the export MiGs were somewhat limited, hard to say how much. The MiG-25s were supplied to Algeria, Libya, Iraq, Syria, India and North Korea, and in decent quantities, and everywhere they got involved in stories of various degrees of drama. The Syrian MiGs were used in Lebanon in the 1970s, sometimes colliding with the Israeli F-15s. The Libyan MiGs conducted reconnaissance and patrolling, also intersecting with the American F-14s. The MiG-25 of the Indian Air Force was used in their confrontation with Pakistan. Once, the reconnaissance aircraft flew at maximum speed right over Islamabad. There was a lot of noise, the Pakistanis could not do anything about it. A big fight awaited the MiGs during the Iran-Iraq conflict. The Iraqi MiG-25s proved effective against the F-4 and F-5s, but the Iranians adapted and began deploying the best they had against them, the F-14s. The clashes in the sky were no less active than on the ground, with varying degrees of success. By the way, most MiGs survived. And then they faced the Desert Storm, where 36 aircraft were confronted by a huge flock of fourth-generation fighters. In such conditions, the MiGs could only bite, but it was impossible to radically change the situation. However, most of the jets were lost not in aerial clashes, but on the ground. Afterwards, the planes did not regain their former power. There were few of them left, and there were problems with maintenance. These MiGs met the year 2003 being practically incapable of service, and some of them were even found buried in the sand. In the post-Soviet space, the aircraft were used in Chechnya and Nagorno-Karabakh, although not on a large scale. Flying a MiG-25 over Karabakh is like riding a sports motorcycle around a small garden. All these aircraft served for a very long time and were actively withdrawn from service at the beginning of the 21st century. In some countries they still serve, formally or actively. One of the brightest peace programs in which the MiG-25 participated was Energia-Buran in the 1980s. Several modified planes conducted flights to study the operation of equipment created for the spacecraft. In 1988, during a test orbital flight, a MiG accompanied Buran on the final stage of its return to Earth. Everything went perfectly, and the spacecraft successfully landed in fully automated mode. There were no people on board. Unfortunately for the program, the first flight was also the last. Buran never saw space again. The 1960s were the golden age of high-speed jet aviation, and the MiG-25 created at that time became the living personification of this age. Having never faced a Mach 3 opponent, it destroyed the very concept of high-speed penetration. Ironically, by eliminating this threat, it eliminated the need for itself as a highly specialized high-speed interceptor. Having become the best representative of this breed, the MiG-25 in fact became its last representative. In general, the fate of the MiG-25 can be considered quite happy. It appeared when it was needed, completed its task, and quietly retired, having had great influence on the current masters of the skies, the fourth-generation fighters. This concludes our story today. Thank you to Patriot Pog for the opportunity to get to know this steel miracle better. Like and subscribe to the channel. And if you want to watch the videos early, see some exclusive behind-the-scenes content, or just support the channel, consider joining our Patreon community. Very fast flights on amazing planes, and soft landings to you.